In this video we'll cover Octave programs, which are called either scripts or functions. They're different in that scripts simply execute a series of Octave statements. By Octave statements I mean commands that you would issue in the command line of Octave. Functions differ from scripts in that they accept arguments and they return values. Scripts and functions also have different scope. The scope of a script persists, whereas the scope of a function does not persist after execution. Now these files are similar in that both scripts and functions are text files and they're saved with a .m extension. Functions are more flexible because of the fact that they can take input arguments. So I'll show some information about scripts and then discuss functions. Scripts, like I said before, is just a way of executing a series of Octave commands. So instead of having to type in the commands one by one in the Octave window, one can write a script and then call that script at the command prompt, the Octave command prompt. For example, we create this text file called simpleexample01.m, and in it we write the 3 lines. So these would be 3 lines that you could write in the Octave command window, but we'll just write them in our script file. So we assign the value 5 to a variable called x, assign the value 7 to a variable called y, and the sum of those two variables is assigned to g. And then in the Octave command window we call that function. So we just write simpleexample01, and then Octave will execute this script. So Octave will then go in and execute the first line, then the second line, and then the third line. And the reason we see this g equals 12 is because this third line of the script doesn't have a semicolon, so we didn't suppress the output of that line. But now after executing it in memory, there is a variable called x that has a value 5, and there's also a variable called y that has a value 7 in addition to g. So running a script is equivalent to just copying and pasting, copying all these lines and then pasting them into the command window. So that's how a script works. It's just a shortcut to allow you to edit a series of commands or to save them for future reference. Just an aside, we'll talk about comments. Whenever creating an Octave program, whether it's script or a function, it's helpful to be able to add comments. So comments are helpful for debugging purposes, to try to figure out what's going wrong with a program, or if you want to reuse a program. So when you come back later, if you need to adapt the program to a different purpose, then comments help you understand the program. Comments begin with a % symbol. So in a script or program, any line that begins with this % symbol, or any text following a % symbol, is not going to be evaluated. So when we call this script circle example 01, the only 2 lines that are evaluated are radius, assigning the value 5 to the variable radius, and then evaluating this expression and assigning it to the variable area. Functions are the other types of program, and Octave comes with lots of built-in functions, and you can also create your own functions. And we'll study this one built-in function as an example and then lead into user-defined functions. So this example is the function length. Length returns the length of a vector. So in the command window we create a variable vec, and it's an array of elements from 1 to 10, and they iterate by 3 each time, so 1, 4, 7, and 10. And then we assign the length of that vector to the variable lv. So this function length takes in an argument or an input, and the argument that it's working on is the vector vec, and then this function returns a value. And the value it returns is the length of that vector. And So we're going to assign the return from the length function to the variable LV. So after executing this line, our variable LV has the value 4 because the length of this vector is 4. So the two important concepts in this example are the argument and the return. For a function, you can have an argument, which is the value that the function operates on, and then you can have a return, which is what you can assign to a variable in the command window. Now, creating your own function is a useful thing because they're more flexible than scripts, although they take a little bit more forethought. So, as stated earlier, functions are stored as .m files, just like scripts. Functions always start off, the first non-comment line is always the same in a function, and it has a specific format, and it starts with the word function, and it's reserved because it can only be used in this application or this scenario. So you start off with the word function, and then you provide the name of the output argument, and then the assignment operator, the name of the function, which should be the same as the file name, and then the input arguments. So the beginning of a function contains this word, output argument, the name of the function, the assignment operator, the name of the function, and input arguments. So for example, the circle example.m file that we looked at earlier was a script, and now we're doing sort of the same calculations, but we're writing a function instead. So the first line of this file has the word function. It has the output argument here, the assignment operator, the name of the function, which is the same as the name of the file here, circle example 02, and then parentheses and the input argument. So then we perform the calculations, so we evaluate this expression. We calculate the area as a function of the radius that was an input argument, and then we assign that value to the output argument, to area. So we assign this value to the variable area, and then when the function ends, it will return the value of that variable, the value of the output argument. For example, once we have this file saved in our working directory, at the command prompt we could create a variable called A1 and assign to it the value returned by circle example 02, where we passed argument 5 to it. So 5 squared times pi is equal to 78.54. So this is an example of creating and using a function. Again, the important things to remember are we have this input argument, and then the return is assigned to a variable in the command window. Now, we can certainly call scripts and functions within other scripts and functions. So here is a script named call function script, and in it we ask the user for a number. So this built-in function input will print whatever we say to the screen, and then it'll wait for a numerical response, and then it will return that numerical response. So we assign that return to the variable radius. Now we have a variable radius, and we will pass that as an argument to circle example 02 function. This is our user-defined function from the previous slide, and the value it returns will be assigned to the variable area. And then in this script we use the fprintf function to write out for a circle with a radius of, and then we have this placeholder, the area is in another placeholder, and a new line, and then that's the end of what we're going to write to the screen. And so for each of these placeholders we need to put the variable that's to go there. So we're going to say, in this example, what would show up would be for a circle, well actually I think it's here. So here's how this could be used in the command window. we will call our script by typing the name of the script and hitting enter. And then the script will start to execute. So the first line of the script calls this function input, and the argument to the input function is this sentence, so input is going to print that to the screen. And now the script, or the input function, is waiting for the user to enter a number. Say the user enters 5. Now after that, the variable radius has a value 5. The script calls the circleExample02 function, passing it the value of 5, and it assigns the return to area. And then the script executes this line, which says for a circle with radius of 5.00. So this is a float with 2 decimal places. That's what this means. The 0.2 and the F. The area is 78.54. So this corresponds to the radius variable, and this corresponds to the area variable. So for the fprintf, you can type the message and then commas separate all the variables. And this last bit is just some details about the built-in functions input and fprintf. So scripts and functions are extremely useful because you can easily go back and edit changes or edit your file to make changes if things aren't working, and they're reusable. So but it's important to recognize the difference between the two. One reason that functions are more flexible is that they accept arguments. So if we wanted to calculate a circle of a different area, we could use this function and just pass it a different value instead of passing it 5. Well, let me see. Here, if we pass this function the value 5, it'll calculate the area for a radius 5 circle. If we pass it 10, it'll calculate the area for a radius 10 circle. That's more flexible than a script, which has the radius hard-coded into it. But scripts and functions are similar in that they're both text files saved with a .m extension.